we go over exponential derivatives. So when you've been given something that is in the form y is equal to a to the power x, such is an exponential function. Now let me give the general form so we know how to find the derivative. Well, if you've been given even e to the power u, this is an exponential function. Now to find the derivative of this one, dy over dx is going to give you, all you get is you are going to get the power which is here. You find its derivatives. So that will be u prime, and then you write the e to the power u, just like that. So that is going to give you the derivative for e to the power u, regardless of what u is. And so what if you've been given y is equal to a to the power u? What will be the derivative where this is not e? Okay, the e here we talk about, this is Euler's number. That is a constant. So now what if we are not using Euler's number? We just get any base. So that will give us dy over dx being equal to, now what we get is, we are going to get this power, we find this derivative. And then the next thing we are going to do is, we are going to write this the way it is. So that is a to the power u. And then now we're going to take the natural log of what we have here, the base. Natural log of what? Natural log of a. It was the same here, it's just that it was natural log, the base was e. But natural log of e is a 1, so we don't put that. So that is basically how we find the derivative for exponential functions. Let's consider some examples. Let's have been given y is being equal to 3 to the power x. So the derivative for this one, dy over dx, we are going to get the power, we find this derivative. Now the derivative of x is a 1. So 1. And then we write the 3 to the power x the way it is. And then we take the natural log of the base 3. So this can also just be written as the 3 to the power x natural log of 3. So this is the derivative then for this problem. What if we have y is equal to e to the power x to the power 3 plus 8x? How do we find the derivative for this? So we take dy over dx, that is going to be equal to, differentiate the power, that is 3x squared. If we differentiate 8x, that will give us 8. Well, and then we write the e to the power x to the power 3 plus 8x the way it is. Of course we're supposed to take natural log of e, but this is a 1, so we don't put that. So this is the derivative, and we shouldn't forget to put the brackets here, because if we don't put them, then what we have found means a different thing. Okay. Now consider y is equal to e to the power sine x. How do we find the derivative for this? Well, first differentiate what is the power. The derivative of sin x is cos x. And then all you do is write e to the power sin x. So that will be the answer for that one. Okay, and then we have got y is equal to 4 to the power tan x. Now how do we find the derivative for this? So again, dy over dx is going to be equal to, we are going to first find the derivative for tan x. Now the derivative for tan x is sec squared x. And then we write 4 to the power tan x the way it is. Again, we take the natural log of the base, the natural log of 4. So this will be the derivative for this one. Well, consider if you've been given y is equal to x squared plus, let's say, e to the power sine 4x. How do we differentiate this? So dy over dx is going to give us x squared. This will give us 2x. And then plus First differentiate the power. Now the derivative of sine 4x is going to be 4. Okay, let me write it like this. So this is sine 4x. Let's say where there is 4x we put u. So let 4x be represented by u. Then we are going to have sine u. So what you do is we differentiate this, and then we are going to differentiate u itself. If we differentiate u 4x, we are going to get 4. If we differentiate sin, we're supposed to get cos. But we're talking of cos u. Okay. Now we know that u is 4x. So this will be the derivative. So this is going to give us 4 cos 4x. And that is, now you write e to the power sin 4x like that. So that is going to be the derivative for this problem then. Let's consider another kind of problem which we can work out when we are talking about these derivatives. So say we've been given y is equal to x to the power 3, and then you've got e to the power 4x. Now what we have here is a product. This is multiplying this, so we're going to use the product rule, and so we're going to say dy over dx is going to be equal to v du over dx plus u dv over dx. So first get the first portion, don't change it, that is x to the power 3, and then we differentiate the second portion. Now if we differentiate e to the power 4x, we are going to differentiate first 4x, that is going to give us a 4, and then we write e to the power 4x the way it is, and then plus. Now for the second portion we are going to take this the way it is, e to the power 4x, and then we differentiate the first one, that is going to give us a 3x squared. So at this point I can also write this as x. Of course this 4 can multiply with that thing, so that is going to give 4x to the power 3 e to the power 4x, and then plus, let's write this in front, so that will be 3x squared e to the power 4x. Now we have got x, so we can factorize out x squared because it's common, x squared, and then we've got also e, both sides, e is also common, e to the power 4x, and so what we are going to remain with here is what? It's a 4x, because it was 4 cubed, but we've just removed, it was 4x cubed, but we've just removed x squared. And then the other portion, what will just remain is a 3. So this will be the derivative then for this problem. Alright, let's consider our last example. We see how we're able to work it out. So say we've been given y is equal to 4 to the power xy. How do we find the derivative for this? So dy over dx is going to be equal to, first find the derivative of the power. Now the derivative of xy, what you do is first find the derivative of one, maintain the other, because this is a product of 2. Okay, so this is going to give us, if we differentiate x, we are going to get a 1, and then we are maintaining the y just the way it is. Again, for the second one, we are going to differentiate a y. Now if we differentiate y, we are supposed to introduce dy over dx. Okay, and that, remember, if we differentiated y, what we got was a 1. So because we've differentiated y, we're supposed to put dy over dx. What did we maintain? We maintained x. So actually the derivative is y plus x dy over dx. So this is the derivative. So we're going to put it there. Y plus x dy over dx. And then we have got, so what do we have now? We are going to now write 4 to the power xy the same way it is, and then we take the natural log or the base. Now the base is 4. Well, at this point what we want to do is to expand, so that this portion which has dy over dx goes to the other side. So this is one portion. we're going to multiply it with everything we can see in the brackets there. So that will give us dy over dx is equal to y multiplied by that. That is going to give us y, and then we have got 4 to the power xy, and then we have got natural log of 4, and then we have got plus, multiply this by what we can see there. So that is going to give us x dy over dx, and then you have got 4 to the power xy natural log of 4. Well, this portion has got dy over dx. We can take it over the other side, and so that is going to be dy over dx minus x dy over dx 4 to the power xy natural log of 4 is equal to y 4 to the power xy natural log of 4. Well, we can factorize out dy over dx, and so that will give us dy over dx open brackets 1 minus what is going to remain there is x 4 to the power xy natural log of 4. Then the other side we have got y 4 to the power xy natural log of 4. Now, to remain with dy over dx, we are going to divide through by the term that is attached to dy over dx. So that is going to give us dy over dx being equal to y 4 to the power xy natural log of 4 divided by 1 minus x 4 to the power xy natural log of 4. So that becomes the derivative then.